So here we take a look at hydroboration, but this time it's the hydroboration of alkynes. Previously we had talked about hydroboration of alkenes, and we know that hydroboration of an alkene leads to the anti-Markovnikov alcohol, or the less substituted alcohol. Now, hydroboration of an alkyne uses the exact same reaction conditions. And also gives us the less substituted or anti-Markovnikov alcohol. But as we'll see when we get into the mechanism of this reaction, at the end there's an additional step that takes place, and that takes place specifically because the alcohol is attached to an alkene. And that's that combination of alcohol and alkene will get converted to a carbonyl. So the hydroboration reaction, whether we're talking about alkenes or alkynes, again, dates very likely to the 1950s and H.C. Brown. Now, how does this reaction work mechanistically? Well, if you recall the hydroboration for an alkene, then to a large extent you already know this mechanism because they are largely the same. But we'll review them here. So in the first part, the alkyne adds to the boron, and at the same time the boron-hydrogen bond breaks and the electrons move over to the carbon with the hydrogen. And if you recall alkene hydroboration, in an alkene, this same mechanistic step repeated itself twice more. And same thing for an alkyne. So that exact step happens 2 more times. And so what we're left with is 3 of these R groups, which is now an alkene attached to the boron. This is the point in the reaction where you add the hydrogen peroxide and the hydroxide. And the deprotonated hydroxide will attack the boron. To give us this intermediate. And then in this intermediate, one of the R groups will shift over, grab onto the oxygen, and kick out hydroxide. And then again, this step repeats twice more. Which gets us to this intermediate. Then we take this final intermediate, which we're going to take over to the next page with us. And with the water that's present, each of those gets broken down to form this structure. This structure, which is an alkene attached to an alcohol, is known as an enol. And when we talk about condensation reactions in organic 2, we'll see just how important enols is. They play a role in a lot of important reactions of carbonyls. But for right now, what we need to concern ourselves with is the fact that most enols are not that stable. And under the right conditions, and the right conditions are usually the presence of acid or the presence of base, the enols are in equilibrium with their carbonyl. And for most enol-carbonyl pairs, the carbonyl is a more stable compound. In this reaction, we know we have base present because we need base to go from the alkyl borane to the enol. So the first thing that base is able to do is that base is able to remove the proton from the OH group. From here, electrons come down, and these pi electrons pick up a proton from water. And the overall result of this reaction is that instead of getting an alcohol out of it like we do with an alkene, is that we end up with a carbonyl. Now, these last two steps, the conversion of the enol back to the carbonyl, you'll notice I've drawn them as equilibrium arrows, and certainly they are equilibrium steps, but these are generally equilibrium steps that very, very strongly favor the carbonyl side of the reaction. So finally here, we can look at a couple of other examples. And what we're going to see is the same thing in each case. We're going to ultimately form a carbonyl, and that carbonyl will be on the less substituted carbon of what was the alkyne. So for the first compound, that would be this carbon, this one over here, and that one. And so now it's just a matter of drawing the product where the alkyne has gone away, and we have a carbonyl on the less substituted carbon. So overall, hydroboration for alkynes, extremely similar to hydroboration for alkenes. The primary difference is that with an alkyne, we form an enol as opposed to just an alcohol, and because we're working under basic conditions, that enol will pretty much instantly get converted into the carbonyl.